Welcome back, everyone, to the eCoreAcademy e-learning platform. Today, my name is AJay Raj, back with another geometry video for you all. And today's lesson topic is all about constructions with polygons. Now, we had previous videos all about polygons and their different types, as well as different properties that are given amongst generic polygons. But that's all going to come into a different perspective today, because we're going to be moving from generic processes into more specific items, such as more specific types of polygons and how actually they're represented in real life through constructions, as well as how they're going to be constructed through their own private properties, meaning there are very specific properties that make them their own specific polygons. Now, before we jump into today's lesson, please make sure to smash that subscribe button down below, hit that like button on this video, as well as hitting that post notification bell to get notified on any of our channel's latest posts at eCoreAcademy. The whole theme of today's topic is to discover what are some common polygons discovered in geometry, and we have already addressed those in previous videos before, but I will be going into depth and by the terms of geometry. We're going to be looking at official definitions and official properties and classifications, and we're also going to look at how exactly you can construct them. And if you don't know what a construction is, please refer to my previous video. I did previous videos on constructing line segments, and also constructing figures as well. So construction is basically when you're taking a figure and you're going to actually draw that out. You're using tools that don't have measurements, so that means you can't use rulers, you can't use protractors, things like that. You have to use raw tools and including paper, pencils, straight edges, compasses, things like that without measurements, and you have to try and construct these figures accurately. So it has to be an accurate representation through hand drawing in real life with the utilization of limited tools. And like I said, that would include, compass, straight edge, which is basically something that you can use to draw a straight line on. And there are many, many techniques that I will get into in later videos as well on how exactly you're going to do that. But today I'm just going to give you the generic feed on how exactly these specific polygons are going to be created. So let's jump right into it. Let's start off with triangles. We're going to move in order of 3 sides to 4 sides. So we're only going to be looking at 3 side lengths and 4 side length polygons for today, and that's because those are different types of polygons once you breach that 4 sides, meaning we're going to be sticking to triangles, the different types of triangles and the different types of quadrilaterals, and we're going to end it off at that because as soon as you get on later and later, you're only going to have regular polygons, which are very simple shapes. And I have already addressed that previously, exactly what they are. So there's no need to go into depth with that. However, when you have 3 sides and 4 sides, there are many different properties and many different specified shapes with coexisting relationships. So let's start off with triangles first. So we're going to go from triangles to quadrilaterals after this. So triangles it is. We'll start off with our triangle classification. We're going to look at how exactly triangles are classified and how they're given their identification with the given properties that they have. So triangles are defined by their sides and angles and the relationships between them. Whenever you're given a triangle, you're going to be given a figure, a polygon with 3 side lengths. It's the minimum amount of side lengths for any type of polygon to exist by laws of geometry. And they're defined by both their side lengths, what actually create their vertices, and their angle measures. So you're going to have 3 side lengths and 3 angle measures, and the properties are going to be separate. So there's 3 different classifications for side lengths for types of triangles, and then there's 3 types of different classifications for angle measures that classify triangles. It doesn't mean that they can both be intertwined, meaning you can have one classification for a side length, but it can also apply for the same triangle in the case of an angle measure. So that's all about coexistence, and I will get into that later as well, but we're just going to be focusing on generic and separate classifications of triangles. And when looking at the properties of triangles, you only need limited information to classify triangles by both their angles and sides. So that's also a very important part to note during this triangle classification topic here, because when you're given a triangle, say for example, the certain properties of triangle, like the interior angles of the triangle have to add up to 180 degrees. And if you're already aware of that, well, then you wouldn't necessarily need to know all three angle measures, because you would technically, in any triangle, blandly, you would only need to know a maximum of 2 angle measures in order to compensate and calculate for the third missing angle measure, since you can subtract those the sum of those 2 angle measures from the total sum of all angle measures in the triangle, which is 180 degrees. So I'm just going to put a little real-life applications of triangles here. So as you can see here, this is a caution sign right here. And I'm sure many of you have seen these on the road, some warning and caution signs. So this is an example of a triangle. This is the top of a house. And it's actually very important because whenever precipitation or some kind of element is coming down on the roof of a house, you don't want that to build up pressure and excess moisture in which the roof gets damaged. That's why it's in a triangular shape, and it's an exact measurement, meaning, you can't just put any type of triangle. It has to be to a certain degree and certain side lengths. And with that given property, precipitation and all of the elements will actually fall and flow off the sides of that roof, so that you have an undamaged and a prospering roof, a prosperous roof. And then finally here, I have a little ladder extension here, and whether or not you really realize it or not, if you're getting some sort of ladder and you're either leaning it up against a wall or it's leaning across one of its own bridges or one of its own extensions, what's actually happening is you're developing some sort of triangle, the floor being the base of that triangle, the ladder itself being one edge, most likely the hypotenuse, the longest side, and then you have either a wall or a supporting beam extending out from the ladder, just as I've shown you here. Those will form a specific type of triangle, but in general they form triangles. Now let's view and get a better understanding of specific triangle classifications, and this is part 1 of that, since I'm going to be dividing these two up by their specific properties, one being angle classification and the other one being side length classification. So we're going to start off with our classification by angles for triangles. Keep in mind this is specifically for triangles. Let's start off with the first type of angle classification. And before we jump into that, I just want to make this a bit of a point. Whenever you're classifying a triangle by its certain type of classification, whether or not it's an angle measure or angle classification, or if it's a side length classification, you're only going to have 3 of each, meaning you're going to have 3 angle classifications and 3 side length classifications. So let's go ahead and discover what these 3 angle classifications are for triangles. So the first type that we have here is the right triangle. I'm sure many of you have already heard of this. This is the most common, and this is where the actual formula for the triangle actually derives from. It's the basics for the formula of a triangle. It's the right triangle. And a right triangle, as the name of the triangle states, is a triangle with a right angle. So if you think about it, that's all the information that you need. Like I said before, you're only going to need a certain characteristic, certain limited amount of characteristics for a triangle, specifically in the angle measure. So if you're given a triangle with one right angle, and you keep in mind that you cannot have more than 180 degrees in a triangle, and since we know that a right angle is equivalent to 90 degrees, that means the triangle cannot have another right angle or another obtuse angle. Therefore, both of those other angles must be acute angles, and therefore it will only have one right angle, making it a right triangle. So any triangle with only one right angle, because you can only have maximum one right angle in a triangle, that'll automatically be classified as a right triangle. Now let's look at obtuse triangles. So as you can see here, if you don't already get the memo, we're basing these triangles off of the 3 different types of angle measures, which are acute, obtuse, and right. And I've already gone over that in basics. That's very fundamentals. So you're already expected to know that before coming into today's lesson. So an obtuse triangle is a triangle with an obtuse angle. Like I said, you can only have a minimum of one right angle, and that's also the same for an obtuse triangle. So you can only have a minimum of one obtuse angle in a triangle, and that's any angle. And that's any angle that is more than 90 degrees. So it's greater than 90 degrees. And you can only have one obtuse angle in a triangle. So any triangle that has one obtuse angle is automatically classified as an obtuse triangle. And finally, by our last angle type of angle, we have acute triangles, which define that triangle itself, and it is a triangle with 3 acute angles. Like I said before, if you can only have a maximum of one right or one obtuse angle, that means you can have a mixture of 3 acute angles. So a triangle can have 3 acute angles to add up to 180 degrees, and an acute triangle is any triangle with those 3 acute angles that add up to 180 degrees. So I'll show you little examples here. So as you can see here, since these angle measures represent less than 90, less than 90, and less than 90, obviously it's going to be an acute triangle, and that's because all angles are less than 90 degrees, which is by the definition of an acute angle. This one, as you can see here, it only represents one angle, so that means it has to be either a right or obtuse angle. But if you look at the identification of it, it's basically saying that the angle measure is greater than 90 degrees, and that's under the definition of an obtuse angle, which identifies this as an obtuse triangle. And finally, we have our right triangle because it forms a 90-degree angle, and you only need one 90-degree angle to represent that. Now let's move on to triangle classification part 2, which we're going to look at classification by sides for triangles now. So now we've just transitioned from angle classification to side classification. It isn't necessarily the complete opposite, it's just a completely different, however. But you can have coexistence, meaning you can have an identification of a triangle through an angle as well, through angle classification as well as through side classification. You're always going to have that. It's always going to be a mix of two from either side, and I'll get into that little coexistence postulate later on in a later lesson. So let's look at classification of triangles by sides. So an isosceles triangle, this should be a new term to you all. An isosceles triangle is basically a triangle with two congruent sides, meaning it's a triangle that has two sides that are congruent, and its third side is not going to be congruent to either one of those sides. And we already know that this is limited information because we already know the properties of a triangle, in which state that a triangle has maximum and minimum 3 sides. It only has 3 sides. Then we have our equilateral triangle, and keep in mind we have 3 of these classification by sides. So we have our equilateral triangle, which is a triangle with 3 congruent sides, meaning all 3 sides of the triangle given must be congruent in order to be an equilateral triangle. And finally, we have our scalene triangle, which is a triangle with no congruent sides. That means all 3 side lengths of the triangle, if it's a scalene triangle, must be of different length and different measure. So let's look at these visual representations. The visuals right here, if we refer back, isosceles states that the triangle must have 2 congruent sides and only 2 congruent sides. So this figure here, ABC, triangle ABC, as we know, these tick marks or these line indications represent congruent sides. So since these both have the same number of tick marks, they're represented as congruent, and therefore we can identify an isosceles triangle with 2 congruent sides. And that's also going to make this triangle, it's going to make this triangle a triangle with 2 congruent angles. So where the 2 sides of these side lengths of the triangle actually meet the base, that's going to be where you're going to have 2 equivalent angles, and that's a property of isosceles triangles, but I will get into that in a later lesson as well. And then over here, as you can tell, we have 3 completely different side lengths because the tick marks do not evaluate all side lengths under the same number of tick marks. Therefore, this must be a scalene triangle which has no congruent sides. And finally, we have our equilateral triangle, and the equilateral triangle has all equivalent sides. And as you can see here, the A on each side represents equivalence because they're all symmetric to each other. And if you look here at the angle measures, we can see that all angle measures are congruent by the tick marks on the arcs or the ellipses, as well as the equal angle measures represented by 60 degrees in each and every arc here. That's because an equilateral triangle does not only have, I'll just write this here for equilateral triangle, it has equal sides and equal angles. And since we know that they're all equal, we're going to divide that by 3 because we know we have 3 angles in any triangle. So we'll divide 180 by 3 to get 60-degree angles. So 60-degree angles, and those are all congruent angles. So 60-degree angles. And I'll just label these here. So equilateral, scalene, and finally our isosceles. All right, let's move on. So now let's look at triangle constructions. Now that we've moved from the identification process, we're going to start to shift to our construction process. And if you don't already know what a construction is, as I mentioned in the beginning of the video, it's where you use a certain amount of tools to construct a figure in real life. And you cannot use any measurements, only compasses, straight edges, paper, pencils, items as such. So you're limited to those specific items. So today we're going to be constructing equilateral triangles, and the only reason we're constructing equilateral triangles is because if you were to draw a scalene triangle, you don't necessarily need tools to draw that. You would only need a straight edge to draw straight lines, and same thing with an isosceles triangle. If you're able to draw two congruent side lengths to each other, you would only need a given compass. But you can use certain given tools to construct an isosceles triangle, but since an equilateral triangle has a qualification of 3 equal side lengths and 3 equal angles, you need certain tools to do that and in order to make a hand-drawn construction. So if you know how to do it for an equilateral triangle, you will automatically know how to do it for an isosceles triangle. So we're just cutting down this process here and not trying to confuse you all. So let's construct our equilateral triangles. So the tools needed to construct an equilateral triangle include a compass, which if you don't already know a compass, I will put that in the description down below. But a compass is basically what's used to draw a specific kind of arc. A straight edge is any edge that is straight, so I'll draw this out here. So a compass is basically a fine point that's symbolized by this, 2 different segments. One side is going to have the pencil, and one side is going to have the point. And as it rotates along its axis, you're going to get some kind of curvature. So it's going to be a curvature. I'll write here, curvature, which can be, if you make a full arc around, you'll make a circle. You can make semicircles. You can make arcs and ellipses, all of those sweet stuff. And then a straight edge is any line that's straight. So this is basically a straight edge. You cannot use a ruler, however, because by the laws of constructions, you are not allowed to use specifically given measurements. And you're not allowed to use protractors either. So this is any straight item that you can use to draw a straight line, excluding a ruler. Straight edge. There we go. And or if you don't want to do this through a hand-drawn construction, you can use geometric software. And in that, you can use certain apps like Desmos or Loom Create. And all you need for those is the information of how large you want the radius of a circle to be and what its intersection is. So if you're confused by what I mean by that, I will show you right now, actually. I will show you right now. So I'll erase this here if you already got that down. And we'll look exactly how the simplistic figure of a equilateral triangle is actually made and developed. So what you're going to do is you're actually going to start by making a line segment. You're going to make a little line segment here. And what you're going to do is with that line here, you're going to try and draw a circle. And this is using the geometric software. You can do that with geometric software, or you can hand draw it by using a compass, putting the compass in the center point of this circle and drawing out the circle entirely. Once you've done that, you'll be given a plain circle as such. And now what you're going to do is you're going to choose a single point on the circle that you've just drawn, and you can label it as point A or any point that you want to label it as. Once you've labeled it, what you're going to do is you're going to try and make a diameter of this point A. The diameter is the distance across is the distance connecting 2 points on a circle. So you can draw the diameter of this this point A here. So we'll draw that here. Sorry about that. Switch this to my pen here. We're going to draw this to another point connecting. We're going to connect it across each circle to another point on the exterior of the circle, which is a diameter of this circle. And then next, we're going to do the same thing and point it in any other opposite. We're going to point it in the opposite direction, meaning that we're going to measure this length here, and we're going to put it in the opposite direction here. And once you've done that, oops, sorry about that. So I'm just going to erase that so it doesn't get in the way. So once you've done that, you can connect that point here as C, and then finally you can connect the bottom points B and C, and you'll be left with an equilateral triangle. And there's some more processes, some more steps that I've skipped because I'm going to be mentioning that in a later video. I don't want to give that away just yet. So equilateral triangle. and that's only constructed through compass or a straight edge, or if you want to, well, a compass and a straight edge through a hand-drawn construction, or you can just simply do that through geometric software. But that's not where you actually learn something. That's more like a calculator purpose tool, and we want to actually find out the physical rules and laws that you have to follow in order to develop the skill. Now let's move on to quadrilaterals. This is our second half of our video. So let's look at quadrilateral classification. A quadrilateral, by geometric definition, is a four-sided polygon. Very simple. It's a polygon that has it's a closed figure that has four sides on it. So it's a type of polygon, and it's all straight edges and connected by vertices. And quadrilaterals in their classification start from a broad classification to very specific shapes, as shown here. So what this basically shows is a quadrilateral family. But even outside of this quadrilateral family, you're going to start with, say, for example, a polygon. A quadrilateral is then a type of polygon because it's a polygon with four sides, so it's a specific type of polygon. And then you have these different kinds of quadrilaterals, which include kites, rhombuses, parallelogram squares, rectangles, which all have interrelated relationships, and I will get into that right now. So we'll start from descending order. We're going to start from quadrilateral, and we're going to break it into more specific, all the way until the very bottom. Let's get right into it. So quadrilaterals classification part one, we're going to start from the most general quadrilaterals, then break it into parallelograms and trapezoids. So the two types of quadrilaterals are parallelograms and trapezoids. So parallelograms are quadrilaterals with two pairs of parallel sides, and a trapezoid is a quadrilateral with only one pair of parallel sides. So I'll give you an example of what a parallelogram is. So a parallelogram looks like something like this. I'm sure many of you have already seen that before. So a parallelogram has parallel sides, meaning that both sides have the same slope, and they're also going to be equivalent. So opposite sides are equivalent of a parallelogram, and they're going to have parallel opposite sides. So these two, this side here and this side here, are going to be parallel and congruent, and then these sides are also going to be parallel as well as congruent. But for a trapezoid, you only need one pair of parallel sides. And if you look at this trapezoid here, this side is parallel to this side, but they are not of the same length. They're not necessarily going to be of the same length. And these two sides are not parallel, so these are not a pair of parallel sides, but they can be of the same length. So that's different types of trapezoids, and we'll also get into that in a later video as well. So this is more generic compared to where we're going to be going later on. But we're going to start off with parallelograms and trapezoids, the two different types of quadrilaterals. And now we're going to be moving into more specific classifications, or quadrilateral classification part two, and we're going to be moving into parallelograms. So there aren't many specific types of trapezoids, but there are existing types of specific types of trapezoids. We won't be getting into that today, but we will be getting into the types of parallelograms. So we're moving from quadrilaterals to parallelograms to the different types of parallelograms. So a rectangle is a parallelogram with four right angles. So remember how I said a parallelogram is basically a figure, a polygon, with two sets or two pairs of parallel sides. So a rectangle is a parallelogram, meaning that it has two pairs of parallel sides, and they're both going to be congruent, but it also has four right angles. So it means it has all right angles at all of its side intersections. And then finally you have your rhombus, which is another type of parallelogram, our second type, and it's a parallelogram with four congruent sides, meaning that it's any parallelogram, meaning it has two pairs of parallel sides, but all of those sides have to be congruent to each other, meaning not only parallel sides are congruent, all sides are congruent to each other. And finally, you have a square, which is a parallelogram with four congruent sides and four right angles. But the cool thing about a square is that a square is actually just a type of rectangle. So it's a specific type of rectangle, and it can also be a specific type of rhombus. So it's both a rectangle and a rhombus. So we're going to start, I'm going to just reincite that. So it goes from quadrilaterals to trapezoids and parallelograms, and from parallelograms you're moving down to rectangles and rhombuses, and then a square is both a rectangle and rhombuses, so that's underneath both of them. So it's a parallelogram. A square is a parallelogram, so two sets of parallel sides. It's also a rectangle, meaning that it'll have four right angles, and it's also going to be a rhombus, meaning it has 4 congruent sides. So it's a mesh of everything, and it's probably one of your most common shapes that you've known, and it's one of my favorite shapes just because how neat and clean you can use this figure for formulas. So let's look at our rectangle. As you can see here, we have 2 congruent sides, and they're both classified as a parallel. This figure is classified as a parallelogram. So these 2 sets of opposite sides are going to be parallel, and it has 4 right angles. So I'll just write that. That's a major characteristic of rectangles that differentiates it from parallelograms. 4 right angles. And then you have a square, which has all equivalent sides and 4 right angles. So it's just a combination between a rectangle and a rhombus, as a rhombus has 4 equal sides and not necessarily given 4 equal sides and 2 pairs of parallel sides, and it's not necessarily all equivalent angles. It's not necessarily specified. So that's something that's going to be by chance and by occurrence. Now let's look at constructing a square. So when it comes to a parallelogram or a rectangle, and even when it comes to a parallelogram and rhombus, all you need to do is calculate equivalent side lengths, and that's fairly easy to do. And you would only need a single straight edge to do it, and you can put markers on that straight edge, or you can just use a compass to write that down. But we're going to be looking at a square because a square is actually the most complex since it has all equivalent sides and equivalent angles. So if you can discover how to do this for a square, you can also discover how to do this for a rectangle, a rhombus, and even a parallelogram as well. So this is the most specific, so this is the most important to construct. So the process. In order to construct a square, construct a line perpendicular to another line, then use the compass to create segments of equal length. So I'm just going to give you a little brief overview of what that is. I will do an entirely separate video on constructing perpendicular bisectors, angle bisectors, equivalent line segments, and of course, triangles and squares and all these different quadrilaterals. But I'm just going to give you a basic overview of what that looks like. So if I'm going to follow this process here. So you're going to construct a line perpendicular to another line. So I'll draw this line here. I'm going to make this a line segment instead. So if I draw this line segment here, and then I'm going to draw another line segment perpendicular to that line segment. So that goes through here, and that forms a 90-degree angle. And there's specific ways to do this. And then you're going to use a compass, and you're going to try and draw arcs on both lines here. You're going to try and draw arcs here. And you're going to try and make intersections of X's with your arcs. This is what the whole process looks like, but I will get into it later. So once you've drawn both of these processes here, you can take that same distance and you can draw that same arc here, and then you can connect the centers of those arcs that you've constructed, and that should form a square. So not drawn, I'll just right here, not drawn to scale. But this is exactly how you would form a square, and it is exact. By no means will it be off like this, like a rectangle, because I don't have my tools with me right now showing you. I will show you in a later video, and I'll make sure of that you guys understand. All right, everyone, that's been it for today's video. It's been the eCoreAcademy e-learning platform today. Please make sure to like and subscribe down below. Please make sure to hit that post notification bell to get notified on any of our channel's latest posts. Please make sure to visit our website at eCoreAcademy.org. We have full unlocked access and bonus packages to all of our videos given here on YouTube. We have integrated quizzes, note sheets, and worksheets to go along with each and every one of our course videos, organized into course studies with all of these bonus features added on our website. All you need to do is make an account and register with our website. We have all of our contact information if you need that, also accessible there. So all you have to do is make an account for free, and you get full access to everything there. And finally, you can always also email us at eCoreAcademy@gmail.com for our communication. You can reach out to us if you have any questions, or if you just want to talk to us outside of what we're doing here. And please make sure to visit all of our socials down in the description box below as well, at Facebook, Twitter, and Instagram. See what kind of content we have there, and help us by sharing all of our videos out there as well, using those mediums. Once again, I hope you all enjoyed. This has been AJay Raj, and I will see you guys in the next one. Peace.